Thank you very much for joining me. This is part 4, and this is a continuation from the previous video series where we're building a USB HID PID flight simulator hardware interface, and this is for Avionics PFD, MFD, or other systems within a cockpit in a flight simulator environment. Here we're going to continue with a few things. One, we're going to modify our code so we can utilize the HID. This is showing the HID structure that I created. The first part of the structure is a structure within a structure, and this is the 16 bits that we're using for the encoder. Currently, we're only using the first 7 encoders from 0 to 6, and this one is reserved currently in case we want to do any other implementation. And just to note, the attribute we're using, packed, will make sure that there's no spacing in between the structure. These 2 bytes cover the 16 bits. The second portion here is an array with 8 additional bytes, and these will be used to capture the incremental values that we're counting by for each of these encoder that we have here in the bit section. So remember, we're using 2 bits to represent the up or down position in an encoder. So as you turn the encoder, it will either go up or down. So these 2 bits will determine that, but the counting values will be in this 8-byte array structure, and those values will be stored in this array here. Earlier in the series, I mentioned that we are bringing these over, but in the flight simulator, we're not mapping them currently to any functionality because these will count up from 0 to 255. We wanted to reserve that in case we needed to use it when we build a custom driver. And why we would need a custom driver, there's certain things we might want to do in the flight simulator, and we'll end up using SimConnect. So whether we're reading data back or entering data within the flight simulator environment. The first 16 bits represent the first 2 bytes of the structure. These additional 8 bytes add up to 10 bytes. And then these 16 bits, there is additional 2 bytes, and then another byte. These are all input. Input meaning what we're sending into the computer with the HID descriptor into the flight simulator. And these are output. So we'll use this for PID functionality output. And we can expand this later. But just so you know, we're using this for output. I'm going to do a small demo to show you how this output data is being represented, or how we are using this to test to show that we're getting data back from the computer. And later, as I move forward, I'll also show you how this structure relates to the HID structure that I created. Okay, so let's continue on. In the main, we added the include fuller interface that we built here. And that's why we included this interface, so that we can utilize this custom header file. The last time we also defined this value, where we went ahead and just to give the number of channels, we're going to use that in an array, but in case we increase it later on, if we add another potentiometer or variable resistor, we might add another ADC channel, and we'll just make the change here. These are the additional variables we set up the last time, and yep. If you want more details, you can go over the previous video. But for right now, we're going to jump in and start making some changes in order to set up the HID descriptor that we'll be using to send data from the board over the USB to the computer so that we can map that on the flight simulator. Just a reminder, we were referencing the B. Montanari article that he did on the ST website, where he implemented a USB custom HID class. And I referenced that when I started this. So it was pretty helpful. So in case you want to go and take a look at it, the link is in the description as well. So let's move on. First thing we're going to do is open the USB D_custom HID header file. So if we go to the middleware folder structure, and we scroll down and we go to the custom HID folder, you can see the structure where I click through. And then in the include folder, you can see this file. We're going to open that file. And within this file, we're going to change these 2 values. We're going to change a custom HID endpoint in, and then the endpoint out. So just so you know, in refers to in the computer. We're sending data into the computer over with the HID descriptor, and out is what's coming back from the computer to the board. And this is the size that we're going to change coming back. So just so you know what in and out represents. So with mine, I changed mine to D because they're 13 bytes we're going to send, and this is an hexadecimal. So remember, the first 13 bytes we're sending in my structure here. So that represents the bytes I'm sending based on the functionality that we're implementing right now. And then these 7 bytes are the output. So when we read data from the computer back to the board, we're using these 7 bytes right now based on how I define the HID descriptor, and we'll go over that. What we're going to do, as I mentioned, we're going to change this. We change this to the 13, which is D in hexadecimal. And then here we have 7 bytes. So we're going to have out 7 bytes and in 13 bytes, a total of 20. So the next thing we're going to do in this file, we're going to look for another change. We're going to look for a structure that we have to modify. And here we're going to modify the structure, and we definitely want to make only the state. So let's go ahead and change that. So I'm going to copy and paste from my previous file. If you notice, this is the key thing that changed right here. In the out event, we're only going to pass one parameter, and it's going to be a pointer. And that's all we have to change here, but pay attention to make sure you have everything else in your code, if you're following along, to match here. And we're going to go to the source, and we're going to open the custom HIDC file. And here we're going to make a few changes as well. The first method we're going to change is the USB underscore custom underscore HID underscore data out method here. Actually, let's go over here and save this first and go back over here. This is the one we're going to change right here. Just going to copy and paste it over. So that's changed. The other method we're going to change is the USBD underscore custom underscore HID underscore EP0 underscore RX ready method. Whenever there's data on the buffer, it's going to just read that for us. So let's go ahead and update that one as well. So that's a change that's made here. This change will reflect the update we did for the out event. Remember, we made a change to the out event. Therefore, we have to also update this section. So that's what's being done here. Next, we're going to go into the USB underscore device folder. We're going to go to target. Actually, before we go there, we're going to go here. And we're going to open the USBD underscore custom underscore HID underscore if.c file. And within here, we're going to change the HID report descriptor. Right now, it comes in as the default, which is not doing anything. So we're just going to update that. And as you can see here, this is nothing. So we're going to update that real quickly. And this is the one that I made. So this is the key to how the data is being sent over HID. So this is what I modified. The other resource that I'll share with you is from the USB website. All the documents that I'll share will be on the usb.org website. Next, we're going to go to the device class definition document. Go ahead and take a look at this document. But for right now, I'll cover what you need, but this is a good resource for you to have. And it's device class definition for human interface devices, HID. The next document that's showing on the screen is the HID usage tables. This is actually the key part to where we will be defining our HID descriptor. Chapter 3 will focus on a lot of the usage pages that we'll use and how to define it. You'll see all these pages when you're defining a HID descriptor. So we'll move on. What I did here, I already set up the structure you will need for this testing, but I want to show you one more thing. On the USB Avionics.org website, there's also a descriptor tool, and you can use this to go ahead and define or to validate the structure. And I'm going to open an existing one that I was using. So we're using a generic desktop. This means it's just a generic desktop or PC device. Then we're defining it, the usage for a joystick. We're not totally implementing all the functionalities of a joystick, but we had 16 buttons that we defined, the minimum, and up to 16. So it had 1 to 16 buttons. The logical minimum represents the value of each button, 0 and 1. The report size is 1 because each button is considered 1 bit. The report count is 16, so there's 16 bits, which will give you 2 bytes. And then this is in the input. We're using a data, and it's a variable, and it's absolute value. That's the structure I used, and I was able to generate the values, and then I was able to save it here. So when I modified it, so keep that in mind. But for right now, I'm sharing this. So if you're using it for testing, you can go ahead and look at this, and I'll scroll down so you can capture the end of it as well. So that's how I was able to define the HID report descriptor. So please note that once you change this value, the length of your descriptor will change. So if the length of your descriptor change, the other values will change in your code. And I'm going to show you where you have to also make a change as well. So if you go here into the target folder, you were in the app folder on the USB device. You were here under app, but you're going to go to the target folder. From the target folder, you're going to open the usbd_conf.h. This header file will show you the values. So we already defined this from when we were configuring our microcontroller. So in the tool, we had enter 14. Well, this is not 14, this is 21. 4 in hexadecimal will be equivalent to 20 in decimal. And then also this is 104 in decimal, which is x68. And this value was what determined the value or the length of this structure that we defined here, just so you know, so you'll have that for your reference. So now that we have that, we can move on. Let's go back to the structure that I defined. This is the same structure as the HID. So I'm going to show you the tool that we just, actually, not this one. In the 16 bits here, it relates to this definition from here, having to do with these 16 bits. And it starts here as a button and end here at the input. So that structure defined the first 16 bits or the first 2 bytes in the structure. In this section, this also defines another 8 bytes, and that will correspond to this part of the section. Starting here, we're going to define dial values for what I am doing, and it will start and it will stop here. So this will be the section that corresponds to this definition that I have highlighted here for those 8 bytes. It's an array with 8 bytes. For the next section, the next 16 bits showing here in the structure corresponds to the values here that I'm defining right here. So those 16 bits, 2 bytes, will correspond to this structure or to the definition that I did here. And the ADC knob, the variable resistor that was being used in conjunction with the ADC values, the 8 bits or 1 byte, corresponds to this definition here. I'm defining it as a dial, and from 0 to 255 starts here and ends here. So it ends right there. So that's what's defining that structure here. This output, 16-bit or 2 bytes output data flags, this is being defined here. So this section is being sent over as a counted buffer. So that variable, the 16-bit or 2 byte data, is the output data flags. The output section is being done in this complete section right here. This output section is handled by the 7 bytes. So just so you know, that's how I defined it. You might have different needs, different values. Use the documents that I shared with you. That should get you started with what you need. All right, so let's continue on. This is the section again that I updated this information from. And this is the custom underscore HID report descriptor underscore HS. And this array structure defines the size or the length of the structure here, and that was being defined here. So this is the value that is being used to determine the length, and that corresponds to this value here. We're also going to make a change to the definition here. Two places we're going to do this. First, we're going to change this function prototype here. Instead of two variables, we're going to change it to just have a one pointer variable, and that's it. So we change it first there, the prototype, and then we're going to go down to the function. We're going to change the function as well. And we're going to replace the function value, function definition with this. What this going to do is going to copy over to the buffer, and we need to go ahead and define that in a minute. So let's go ahead and define that buffer. I'll show you where it's defined. We defined it in the main already, but because this is the buffer that is the output buffer that we're getting the data back from the computer over the HID. The data coming over from the USB is 7 bytes. We're sending 13, but it's sending back 7. So this is the buffer that's gonna save the information there. So we defined it there, but we have to also make sure that we specify it here in this file as external. And right here in our variables, this flag will alert whenever any data comes in. But for right now, that should be it in this file. We are good here. All this is doing is copying the value from the state, and it's basically copying it to the buffer. The other thing, we also need to change the signature because we did change the prototype. So we also have to do the corresponding function and change the signature here as well. So let's go ahead and change the signature here. There it is. So let's go to the main file, project, clean. There's one error. Let's see where's that coming from. Oh, undefined reference to the RX flag. Hold on just a minute. Okay, yeah, I just need to add these variables real quickly in the main. So let's go ahead and add these variables. Okay, these are the flags that we're going to use. So I don't think we're using this one anymore, but let's go ahead and clean the project again. All right, so that works. All right, so let's go ahead and debug it. So let's confirm a few things from the last time that everything else is working here. And let's go ahead and turn on the camera for a minute. So, yep, we'll test a few things. That is working. The knob is working. And buttons. Actually, I don't have the buttons. Actually, let's do the encoder. Encoder is counting up and down. Perfect. And as you can see, the values that are changing here. So encoder 1, as I turn the value is changing. And then encoder 2, here the value is changing as well. So there it is. So that's working, and we can confirm the buttons as well. And buttons here. We have that one. Those are working. Those are the buttons we defined. for this use case. So, all right, so that's a good thing. Let's move on from here. Let's turn back off the camera and start back in the code. Let's go ahead and debug again. And let's move forward. There it is. So you can see the LED blinking right here. So we're going to disable that and then start sending over the USB. So signal. We won't toggle this anymore, and we won't delay. We'll remove the delay. That was just for testing purposes. This is a key part here. Remember, I created a pointer as an alias to this beginning structure here we define, this variable, and this variable corresponds to this structure. And we're sending the first 13 bytes of the structure. And this is the first 13 bytes that we're sending over. We defined this pointer that will be mapped to this address, and then we're going to send over the first 13 bytes. And that's what we're going to be doing here when we send the report over. We use this method that's included in the drivers we're using. So if we open the declaration here, this is a part of the USBD custom HID.c file. So that is what we're sending over. We're using the pointer to the structure, and the length is 13. So we only want 13 bytes of that structure to send over. And that will correspond to the descriptor we already defined. And remember, this section resets the first 16 bits because it corresponds to this pointer here, which represents the structure here. And we're resetting these first 16 bits. That's all this section is doing. It's resetting those bits. And this will send it 200 times because it's going so fast. It cannot register if you were to just send it once and disable it. Everything is the build-up to send this over to the USB. So we're going to do a test right now. And let's debug. So this board comes with a USB-C port. So it's here. You probably won't be able to see it unless I move this down. It comes with a USB-C port, so I have to plug in this USB-C cable first to connect it to the computer. Using this utility, I was able to connect the USB device. If I turn the values here all the way to the right, that's for the potentiometer or the variable resistor. That will show the values there. And as I turn it, you can see the values. So those are the values for the buttons. And then from here as well, it will change the last column from the right, or the second column from the right. You can see the value there from there. Very good. So yep, second from the right, the value there will change. Remember, if you look at these values, you can see them changing accordingly, for which it's the bitmap for each button being pressed. And then if we start turning the encoder, that's for the second channel. And first channel. There we go. So that's working. In the first video, I mentioned that we can send values back to the board. I'm going to go ahead and show you how that is done. So let's actually move this for now and disable the camera. Let's go ahead and stop the debugging for a minute. And we're going to go over here. Okay, let's remove these. We won't use these anymore. Those are for demo. So we'll just remove those toggling and delay. We're not going to delay anything here. And we're going to, in order to show you the output, okay, I'm going to paste a small block of code here that will handle the output functionality from the board. So what this section of code or block of code will do, when it receives data, this receive flag will become 1. We can check if the first byte is equal to 1 or if it's equal to 3. If it will disable the light on the board, and if it's 3, we'll turn it on. So let's go ahead and look at that real quick. Remember, when we did this in the custom HID section, in the usbd underscore custom underscore HID underscore if.c file, this is on line 224, where we had the custom underscore HID underscore out event underscore HS function. This is a event handler, and once we receive data coming back or the computer sends out, it will run this and it will copy the values to the buffer that we defined. But more importantly, it will hit the flag and enable it that data is received. Once the data is received, we can control the LED, and that's what we're showing here. And we'll go ahead and run that right now. And let's turn on the camera so you can see. So if you notice, it's on right now. The LED is on. I'm going to open the tool real quickly. There's the device. You can turn the encoder. We can change the values here on the potentiometer. And so now, if you can see this section where it says report ID, right in the first byte that we're sending back, that corresponds to this section. So this is a 2-byte or 16-bit. And based on this value, we can now go ahead and change it so you can see what will happen. So let's go ahead and open this back up. So this is the simple HID write utility, and we're going to go ahead and enter a 1. If you look at the board here, the light is on. But once we send 1 over and we're going to set the report, hit the set report, watch what happens. It turns off the light. So we can send data back and forth now. So if we go ahead and type 3 here and hit set report, it turns back on the light here. There it is. So this is just a simple demonstration that we can send data back and forth. I'm going to turn it back off now, and it's off right here. So this is simple demonstration that it is working, sending data back and forth from the USB device. So the next thing we can do is load this up in the flight simulator and show you that it actually maps. Okay, we have the simulator up, so we're going to do a free flight, and if we're fortunate, it should already map to what we were using before. So let's just pick an airport, anywhere. Let's just go to San Diego, set as departure, and we're just gonna start a flight. All right, we're not gonna fly, this is just to go ahead and show you that this is working. From video 1, we already mapped the encoder 1 and 2, so we can test and see if it is actually mapped to. So if you look to the right, you can see in the nav frequency, the top left, you can see nav 1 is mapped, is counting down. Let's go to 6.5 and turn on the cam. Let's move this over a little bit for you. There we go. The encoder, second encoder changes the frequency whole number, and then the decimal is the top one. So top one, and then the lower encoder changes the whole number frequency. So let's go back up to that, and let's put it there. So I want to show you the buttons as I am doing this. So again, notice the buttons are lighting up accordingly. So let's go back down to 113.5. Perfect. If we press the button, it's lighting up, so we can switch. So we had mapped it to switching back and forth. So let's go in here and go into the, so you can see these are the buttons that were mapped for the increase and for the decrease. And the swap button, button 18, let's show it to you quickly. One will increase the nav1 frequency, and if we're turning it down, on encoder 1, 2 will decrease the value. And if we go to encoder 2 now, if we're turning it up, 3 will increase, and button 4 event will decrease the value. And if we wanted to switch the values, that's what's doing. This was mapped to the swap, and this is also mapped to swapping the COM right here. And these other buttons we didn't really map, but that's just to show you the functionality. So we were able to get from video 1, where we show the board. Video 2, we configure the microcontroller. Video 3, we did the software changes. So now we're in video 4, where we tied it all in. We enabled the USB HID, and we show the descriptor that we added. And then we were able to go ahead and map it to the flight simulator, or show the mappings in the flight simulator. So at this point, it will be just improving functionalities on the board, and I'll come up with other videos as well. But I really appreciate you taking the time, and thank you very much for your support.